6つ目のセッション基調講演、メドテックスタートアップのEXITを成功させるのに必要なこととはと題しまして、エドワーズ・ライフサイエンスコーポレートバイスプレジデント、アドバンストテクノロジーチーフサイエンティックオフィサー、トッド・ブリントン様にご講演をいただきます。それではトッド様、よろしくお願いします。Mr. Todd Brinton, please come to the stage. 大きな拍手をお願いいたします。
Wonderful. Thank you very much for the very nice invitation here for this event, and thank you for all of you being here. First of all, I want to take the opportunity to reflect a little bit on kind of what I'm going to talk about today. The goal here is to share a little bit about my own journey and my own experience in innovation from multiple perspectives, and I'll walk you through that as we kind of go through the slides. And hopefully it'll give you kind of some kind of insights on some of the things that I think are important as I've learned along the way in my own career. So let's start here. Something I think we all hopefully share. An interest in innovation, which I think can be defined in lots of different ways, lots of different definitions depending on who you ask. I said this earlier today. I think that many cardiologists and cardiac surgeons here in the room, if you ask 10 cardiologists or cardiac surgeons their opinion, you get 11 of them. So the same thing will be true for innovation. There's lots of different ways people define innovation. I myself are going to basically define innovation based on my own experiences and my own reflections of things I've done in my career, and I thought I'd provide those as kind of a perspective. So the first is kind of my perspective, my own history and the things that I've done along in my career. So for those who don't know, I was educated as a biomedical engineer in the university, initially in biomedical engineering, but I also worked as an engineer for 5 years. I spent time in a startup and the experiences and had some unique perspective on what it's like to be in a startup environment, starting with a company that was really 2 guys and a dog. That was it. That's how we started. And it was a job I got right out of the university as an intern, and eventually helped them raise venture capital money. Was able to have the opportunity to not only do core engineering and clinical engineering, got to submit an FDA regulatory study, got the opportunity to pitch for capital, got the opportunity to actually grow with the company as it actually evolved. I then left actually and became a clinician. I trained in medical school and then did an internship in residency in internal medicine, cardiology fellowship, and interventional training at Stanford. And then I went on to the next stage of my career, which was to be an entrepreneur. I was an entrepreneur as a clinician. I started in my career 4 companies. I've been involved as an officer in 6 companies prior to my current role as a 7th. I've had a perspective of both failure, lots of failure, lots and lots of failure. Okay, so if you're not comfortable with failure, get comfortable with failure if you're going to be an innovator. Because the reality is failure is inherent to inventing. It's inherent to innovation. You have to fail. Because I inherently believe that the way you learn as an innovator is by failing. We take for granted every day the things that go well. If you walk across the street and it goes well, we don't think about it. If you walk across the street and trip and break your ankle, you think about it a lot. So the reality is it reinforces failure is how we learn. And I've been involved in multiple different companies, again, founding 4 companies, not all of those successful. The first 2, not successful. The third, I think we can say Shockwave Medical, very, very successful. And Shockwave would have not been successful, at least for me, if I had not had the first 2 experiences before that. I never thought I'd be an academic. I never thought I'd be at a university. I certainly never thought I'd be a full professor at Stanford University. I was lucky enough to become a full professor and then left 9 months after becoming a full professor to take on my current role at Edwards Life Sciences, something that some people wouldn't do. It was a new challenge for me. It really leads to my last perspective as an executive. As an executive in a large cap strategic company that is really dedicated to a specific field, I see things that I used to see differently now being on the other side. I used to talk to strategics, Boston Scientific, Abbott, Medtronic, J&J, and I thought that I knew what they were thinking across the table when we were talking about building a relationship or their interest in my technology or their interest in our project. So I say this because of my perspective on innovation is really influenced by the things that I've been able to do, and it's changed over time. It's evolved. So when I think about innovation, I also think about this. What are the strategies for innovation? And probably the one that comes to mind first is tech push. That's what most of the innovation we're mostly familiar with. If you look at the iPhone that's in your pocket or your Apple phone or whatever, Google phone or whatever you have, the reality is it has created the opportunity to solve problems differently by being faster, by better battery technology. The needs have grown because the technology has grown, not the other way around. And it's a great way to invent. It's a great way to create new solutions and to innovate. But probably the technique that I've used the most and most familiar and is most familiar in med tech is needs-driven innovation. Well-defined problems that are so deeply defined, something that I fundamentally believe in, and Shockwave was the best example of this for me, and I'll walk you through it, was that it was so well characterized that it lent itself very well to the solution. It obviously is a very creative solution using lithotripsy inside a balloon, but it was built on the idea that we defined well the need and what we needed to solve. So I believe this relationship between need and technology is fundamental to understanding the innovation process. So when we think about innovation, probably the process that many people have thought about uniquely when it comes to user-centered design is this iPhone, right? So everyone knows that Apple came up with the iPhone, right? Wrong. Apple produced the iPhone. Do you know who actually invented and created the iPhone, the design? David Kelly did, IDEO design. And the idea was based on this fundamental belief of design thinking. User-centered design, this idea that you empathize with the user. You associate yourself with the customer. What does the customer need who wants to use a mobile phone? How do you define the problem? What problem are they trying to solve? You ideate, you invent lots of different ways to solve the problem, and then you prototype, you test, and you repeat, right? Great technique, very effective, been very effective for many things like the iPhone. But it is not necessarily the same if the user is the eight-headed monster called healthcare. Healthcare does not have one user. It is unique. It is not like technology. It makes it much more complicated. In our case, our user is not just the patient. Our user is not just the physician. Our user is not just the hospital. Our user is not just regulatory agencies, here PMDA, the United States FDA. We certainly don't think it is payers, lots of different payers, whether they're government payers, private payers, the complexity of Medicare in the United States. We don't think of it as also all the other things that come into, like people that go public with companies and how they finance them. The New York Times writing reviews, the American Medical Association creates codes basically for reimbursement in the United States. Obamacare, the healthcare supply, for instance, was a very big change for us 8 to 10 years ago in the United States, and the changes that are going on today under our current president in the United States. This is the dynamics of healthcare. It is not a single user. Therefore, understanding the need, understanding the value is much more complicated. So I believe innovation is fundamentally about process. I'll say that again. Innovation is about a staged process. It sets up for creativity. It is not about a spontaneous idea in the shower. That is not innovation. That's something that happens by accident. That's a spontaneous thought. It may be brilliant, but that is not innovation. Because we all need a repeatable process that we can do over and over to be able to be a serial successful innovator, not a single one-hit wonder. So I believe that innovation needs to be set as a process that sets up the opportunity for creativity. So I'm a fundamental believer in biodesign. Obviously, you are too. An important thing that changed my career along the way. I was a fellow basically in biodesign in 2003, 2004 at Stanford during the earliest years of the program. The program for biodesign started at 2000. It was started by Paul Yock and Josh Mackauer. When I was a fellow, Josh was actually the fellowship director. When Josh finished the year with me, I became the fellowship director and ran the fellowship until 2019. I learned a lot from that experience, but what I learned most is that this process really did change the way I think about innovation. A really different way that I think about how to create value. Value to the entrepreneur, value to the system, and value to strategics that are interested in acquiring technology, to building value that ultimately serves patients. So what is unique about biodesign? These three fundamental steps identify. I know it's just an image on the diagram, but what are we really trying to do? We're trying to identify fundamental, unmet, and often latent unmet clinical needs, where the big opportunities are. When someone says that's not a problem, it's usually an opportunity. We're trying to create a set process for inventing something completely novel, but something novel that solves a fundamental problem, that the invention has to match up well with the fundamental identification of the need. And then an implementation strategy, the tools for how you move forward. What do I like about this? Shockwave was built on these fundamentals. Shockwave was using this fundamental process. I'm going to walk you through each stage of what we did. It's an assembly of milestones. It was rigorous. It allowed us to follow a process. And ultimately, it was all about process and setting ourselves up for creativity. So, this is a slide I throw into a lot of talks because I think it really kind of fits the note here. The number of things I've gone to where people talk on a chalkboard or give a lecture and they kind of squiggle something on the board and out pops Abbott, Boston Scientific, J&J, Medtronic, or even Edwards. The reality is you need a process. You need someone to give you the details of kind of how to do it. And the truth is, like I said before, you're probably going to get 11 opinions from 10 different people on the best way to do it. But the key is there are certain fundamental steps that are important to understand to create something new that no one's ever created before. Creating from a white piece of paper when you've got clinical risk, medical risk, engineering risk, payment risk is really, really hard. So taking the resources and training you've had to put those things together, you need to actually be able to follow a recipe. And that's really what we and what I was able to achieve with using biodesign for Shockwave. So I am a fundamental believer that a well-characterized need is the DNA of a great project. As I said, Shockwave was the third company I founded. I founded with Daniel Hawkins, John Adams, and myself, John the engineer, Daniel the marketeer, myself the physician. And we worked together for a number of years. John bowed out of the company in the first several years. Daniel became the CEO and ultimately exited the company in 2017. I stayed till 2019 until we IPO'd. We IPO'd in 2019, and then people will ask, well, why did we IPO? We IPO'd as a mechanism for financing the company. It was not an exit. We didn't think it was an exit. It was a way to keep growing the company, to keep building the company, to ultimately create enough value that J&J MedTech this last year acquired it because they thought it was an important thing for patients, an important way to develop value. And I really believe that it was because of our well-characterized assessment of the problem. So walking you back in history of what happened, when we started this company and we said we wanted to treat calcified vascular disease, people said it wasn't a problem. It wasn't worth solving. There was no market for it. We couldn't raise money. We tried for 24 months to raise capital. Nobody would give us money. And yet the company exited for $13.3 billion last year. What does that tell you? It tells you that people don't always know everything, and it's your job to exploit the opportunity. It's up to us to create the value step by step along the way. So how did we define the need? We defined it in some of the fundamentals of biodesign. We used a need statement. We had a well-characterized problem. Our problem was calcified vascular disease. It was stenotic calcified vascular disease. Our population, elderly patients with claudication of the limb. Outcomes, safe and effective at dilating the vessel. That was it. That was our fundamental. Seems basic. It took us a year and a half to come up with that. A year and a half of debating what we're going to work on, how we're going to work on it, what our problem was, what our population was, in what time domain, and ultimately how we were going to measure outcome. But ultimately, that became the starting building blocks of our ultimate need statement, which became kind of the guiding light for us for the next 15 years of how we created our clinical strategy, our R&D strategy, our corporate strategy. So these, to me, have become the most important elements that are often outlooked. We talk about the need statement, but the need statement is based on these fundamentals. Disease state. You got to do the work. You can't cut the corners. You have to understand the biology. We had to understand what forms calcium. We went to the experts all over the world. I remember meeting with some of the OCT experts here in Japan. I remember meeting with Renu Vermani, the great cardiovascular pathologist who told us how calcium is formed, why it's formed. We know what everyone's biggest fear was? That the calcium would go someplace. When we dilated the vessel, it would go downstream and clog the vessel. What we didn't understand, and what most people understand, is that the calcium is sandwiched in the wall of the vessel. So breaking up calcium when it comes to lithotripsy of kidney stones, one of the biggest challenges is lithotripsy causes momentum of energy, and the calcium breaks up into pieces. So one of the great breakthroughs in lithotripsy was adding gel to actually hold the particles together. We didn't need to do that because it turns out that our calcium was already embedded in a gel. It was embedded in the vessel wall. So we started to understand what the fundamental disease, what the progression. People said, well, what happens after you crack it? How many years will it last? What will happen after? Our answer became, it doesn't matter. Because if we take it from here to here and it hardens again, we now have an open vessel. So we had to understand fundamentally what the disease was, how the calcium worked. What would happen if it fractured? Would it break up? Would it cause other secondary problems? We went to the experts and really asked their opinion. Why did we have an unmet clinical need? Because the existing solutions didn't work. If those existing solutions really worked, we didn't have an opportunity. And really the only solution that worked in the endovascular space was rotablator. Rotablator was a very effective tool. Rotablator drilled very effectively through calcium, and every expert thought it was fantastic, except for the fact that every time I pulled the rotablator out in the cath lab, the staff hated me. They hate setting it up. They'd hate all the work to get it ready. They hated the complications. And if you ever perforated basically doing rotablator, you'll know what I mean by complications. It's always a big exercise. Yes, it was a tool that worked, but it had a lot of problems associated with it, and it caused a tremendous amount of injury. Our goal was dilatation of calcium without injury, safe and effective. That was our goal. That's not what lithotripsy, and that's not what rotablator was. Rotablator was a very effective tool with a high complication and very difficult to use. And no one felt comfortable using it, whether they wanted to admit it or not. What about the market? We had to understand the market. Most physicians don't want to take the time to understand the market. They don't want to do the work. They don't want to understand the dollars, the number of patients. They say there's plenty of patients. I'm sure it'll work. You have to do the work to understand the market. How many patients there are in claudications? How many patients are claudicants versus those patients that have acute thrombosis, for instance, who come up with a cold limb? And then what about coronary opportunities? What about all these other things we could do? How big are their markets? What are their risks? And was the physiology and biology of a vessel in the leg the same as the vessels in the coronaries? A question that we're still trying to answer today if you look at the clinical trials going on in vascular science. Are they the same? Are they different? We knew one fundamental thing that we learned at the very starting. We needed a technology that was very deliverable. We needed a technology that could slide and move. The insight we had is what technology existed 15 years ago that crossed the lesion 99% of the time. It was a front-end balloon. A very compliant front-end, low-profile balloon crossed 99% of the time. Not 100% of the time, but 99% of the time. That was our spec. We wanted something that was equivalent to that. Once we created that insight, we said, how can we have that balloon and have it change its behavior when it gets there? We said, well, how do you break calcium basically inside other parts of the body? Lithotripsy. How do you create lithotripsy? Inside fluid. Well, a balloon has fluid inside of it. Can we do something there? And that's how the process happened. But it was because it was well characterized and we understood what the fundamental problem was. And then there was stakeholders. Who does claudication treatment globally? Depends on who you talk to. Interventional cardiologists, vascular surgeons, interventional radiologists, angiologists in Europe, which I didn't even know what an angiologist was till I spent multiple years in Europe. These are all differently regulated, differently trained, different experience with different terminology, and they were all trying to do a similar procedure. These were the stakeholders. They all were looking for something slightly different at the same time they were looking for commonality. They're ultimately part of the decision-making process, but not all of it, because their hospitals, their institutions were the ones that were ultimately decide whether we were able to actually take this forward for patients. A very significant executive at one of the large corporates used to tell me, I love this. I love how it works. It's incredibly exciting. Just show me how to pay for it. If I can pay for it, we will buy it in 13 seconds. That's because we didn't initially define the value we created. We knew we created value, but we had to define it. And that was part of the stakeholder process. So, in characterizing the need, there are these 4 pillars: disease state fundamentals, stakeholder analysis, existing solutions, and market analysis. We needed insights to help us think about how disease state would fit with stakeholders, how it would compromise or complement existing solutions, and how it would play a part in our market. To ultimately characterize these things: what was the clinical problem? Calcified vascular disease, the specific population we talked about, elderly claudicants, and a measurable outcome, the dilatation, the safe dilatation of a vessel. That was it. That's ultimately was the foundation for Shockwave. Seems relatively basic, but it took us a long time to get there, and it took it even longer to raise money to be able to do so. How did we do it? I will tell you that we spent a lot of time observing. We didn't spend a lot of time reading. You read to understand the basics. You've got to get in front of the patient. You've got to get into the problem. Looking at OCTs, looking at the biology, looking at when physicians are frustrated. When there is an opportunity. Those opportunities were clear when you watch someone pull out a rotoblader and you saw them perforate or difficult to use or frustrated or not how to do, that there was an opportunity to do something better. It did not mean that it didn't work. It just meant there was a big opportunity out there for something better. So, I think the best concepts are the clearest reflection of the underlying need. So we spent, like I said, 2 years almost, 18 months, defining the need. What did we mean by defining the need? What the problem was, what the population was, whether we were going to work on side populations or not, what the outcome was, how we designed the first clinical trial, how we designed the animal studies, how we designed the bench work. Because if we designed those right and how we're going to measure it, without even knowing what our solution was, our solution would be that much better. If we knew exactly what we're going after, we would be able to define a very good concept. We would know the specifications of that concept and the size and amplitude of the impact it needed to have. So in our finding process, we knew that we had the opportunity to start with lots of potential needs. And when I say needs, it could have been vascular calcium in claudicants. It could have been coronary calcium in acute coronary syndrome. They were somewhat a related problem. It could have been acute thrombosis or fundamental ischemia in patients in the SFA, or the popliteal, or distal tib. It could have been the LAD, the circumflex. It all needed to be characterized. And ultimately what we did is funneled it down to one fundamental, unmet, truly unmet clinical need. And that was a solution for claudicants. We started above the knee with claudicants, not below the knee. It was messy. There was going to be two. We would get there over time, but we started with claudicants and the SFA, above the knee disease. There was enough of them to warrant the problem, and we knew that we could build a larger balloon that would be easier to treat, and we would start peripheral. We talked to 15 or 20 expert CEOs, expert innovators, and said, should we start in the leg or should we start in the coronaries? 50% of us told us the leg, 50% of them told us the coronaries, and they all had great reasons for it. So we had to take the path that we thought was best for us, and the best path was start peripheral and translate to coronary over time. Because if we could develop it in a larger embodiment for the leg, we could develop a very deliverable small device for the coronaries over time. So one of the major challenges in working on a new innovation, I call this the granddaddy of the problems, is there's a lot of data out there. How do you define it? If you read everything, and people said you gotta gobble it all up, you gotta read everything, every study you have to understand, it's confusing. So when you start, you need to limit down to the fundamentals. What do I mean? This was one of my favorite slides. We're not trying to create the Mona Lisa with our first need statement. I told you what our first need statement was. That's not where we ended up. But it was good enough to start really well defined and creating value. We wanted the thing on the right, which was basically a sketch, kind of a paint by color, something I could do. I have no chance of even getting anywhere close to painting the Mona Lisa. That would take an expert many, many years to be able to develop. We wanted just the fundamentals. We wanted to really define the problem, really define the population, very specifically, and how were we going to measure success specifically? And we told all of our early investors what they were so they knew what to expect, and we created early milestones that met those. So, where are the pitfalls? The number of projects I now see as an investor, as a strategic, of people that are doing things that have some kind of effect and an outcome, but they can't tell me how it works. They don't know what the mechanism is, but they look like it's an association. That's difficult to fund. It's certainly difficult to solve. We knew we were trying to crack calcium. We knew what its thickness was. We knew what calcium oxalate was. We knew what the material was. We even created calcium oxalate stones in our lab and tried to fracture them. We knew exactly the material and the frequency and the amount of pressure that we needed to create with lithotripsy to fracture different thicknesses of calcium. So how in the world would you expect to solve the problem if you haven't understood what the mechanism was? So one take home for whatever your projects are, you need to understand what the mechanism of action. I'm not interested in funding projects that I don't understand the mechanism of what is happening. If it happens by chance, good for you, but it's not something that most investors want to fund. This is another challenge. People love big markets, right? Investors like big markets. Edwards likes big markets, right? We like things to be big. The challenge is when they get bigger, they become more heterogeneous. The opportunity gets bigger, heterogeneity goes up. The number of patients go up, the heterogeneity of the population goes up. It's biology. We're all different. And the more difficult it is to solve, solvability goes down. So you need to find the sweet spot where the population is big enough, but it's the most homogeneous population. Let's go back to our need statement. Our need statement, particularly our population, was elderly patients with claudication. Why claudication? Because it turns out that acute thrombosis or critical limb ischemia is very heterogeneous, caused by lots of different mechanisms, very dirty, hard to manage, lots of different mechanisms, stasis, all sorts of different abnormalities that can promote it, and therefore it can be different. We could do the procedure right and still not have the right outcome. Claudication is a narrowing that is based on supply and demand. Very easy physics, and so we chose that as the easiest target because it was the most homogeneous. It didn't mean that we weren't going to potentially treat acute thrombosis down the line, but we wanted to start and deliver value to the simplest embodiment that we could find that created enough value, enough patients to really show that the technology worked and was meaningful. And then there's this one. It turns out that your need value has to be greater than your solution cost. The value you create for the need has to be bigger. If the solution's too expensive for the need it solved, you got nothing. You haven't created value because the value is the delta between the need value and the solution costs. It's very basic, but when you put it fundamentally down, so what were we doing? We were treating vascular disease that was often treated in the OR. We were avoiding surgery with a percutaneous solution, and hopefully we're not injuring and getting restenosis. Our view was low pressure dilatation, less than 4 atmospheres, with lithotripsy that was causing pulses that were 20 microseconds in length, were at 60 atmospheres. Very, very strong pulses. Lithotripsy is the opposite of ultrasound. High amplitude, low frequency. Ultrasound, high frequency, low amplitude. We were doing the opposite. We wanted big pulses to crack the calcium, but by cracking the calcium, we wanted to make sure we could fracture thick calcium, but we wanted to be at low baseline fracture. So the rest of the time, we were at very low pressure for a little injury. We're hoping to not tear the vessel. In doing so, if we could do that, we could create a lot of value. And if we could realize that value, we could pass that value on to patients and to the system. So these were the 3 challenges we needed to overcome. We defined the need, not the solution. We characterized it of the must-have. We needed something that was very deliverable, as I said, that crossed 99% of the time. Not 98% of the time, not 96% of the time, 99% of the time. So it was a must-have of 99%. A nice-to-have would have been 100%. It crossed all the time. But we didn't need that, but we needed it to be 99%. That's what we decided when we talked to physicians. They would change their behavior if it crossed 99% of the time. We wanted it to be working at less than 4 atmospheres. If it was higher pressure, more injury, physicians told us they thought that was probably not a great idea. If we could be at low pressure, and everyone miraculously came up with the same number. We said, how low a pressure? They said, I don't know, maybe 4? 4 kept on popping up, so we put that as our must-have. We had to be 4 atmospheres, not 5 or 6, because what happens when you go to 5 or 6 is you get needs drift. All of a sudden, the solution changes. We wanted to be very specific, binary. The must-haves had to be met. We rejected any concept that didn't satisfy it. And we actually had lots of concepts. So we ran it like anything else, any project. We had lots of different needs defined different ways. We talked about acute thrombosis. We talked about acute coronary syndrome in the coronaries. We talked about claudication. And we ran a schedule of when we brainstormed, the solutions, the number of solutions we came up with, and when we came up with the solutions, how successful they were. And concepts, we had lots of concepts. Not just one concept. It was not one thing. We had different pulse frequencies. We pulsed 20 times faster than we actually initially did. We saw what the effect of that was. Did it actually help us? Did it use up more energy? All we did is fracture basically our electrode. We just destroyed the electrode without destroying the calcium if we went at high frequency. So we went at low frequency. We tried lots of different concepts, but ultimately the final concept was not the concept we loved. It was the concept that best satisfied the need, the simplest way. If you had told me to pick the concept before we did this exercise, I would have chosen a different solution. But we went through this exercise and let them all compete head to head and chose the concept that best satisfied the need. We were a multidisciplinary team, and I had the opportunity to meet with several entrepreneurs earlier and folks from government agencies. And one of the questions came up of, what do you think about a physician CEO? I think it's great having a physician CEO, but no one skill set is going to be enough. I believe that multidisciplinary teams, we were an engineer, a marketeer, and a physician. Again, we got lucky. We came together with different skill sets, different languages, and different experiences, and it gave us lots of conflict, lots of different opinions, but hopefully we ended up in the right place. Having a different skill set is really valuable, different backgrounds. But more valuable than that is my advice on this. I had the opportunity to run the biodesign program at Stanford for 15 years. Each of those had 3 teams. So you take 15 times 3, you got 45 different teams that I ran over those years. Plus I have teams now I run at Edwards. And this is the thing I can take away. Every time I wanted to make sure I have engineering talent, medicine and science talent, and business talent. People of different backgrounds, different experiences, different language they speak, different perspectives. But the most important element is every time I haven't had these 4 components, an analytical thinker, a builder, a domain expert, and an organizer, the team was not successful. Now, it doesn't mean you need 4 different people. It means that some people you can have a person who's a great analytical thinker and builder, and the other person is a great domain expert and organizer. But when I was missing one of these key components, the team was not as successful. That was on me. I built the teams. So I build teams now with this in mind. I look at the teams in background. When I used to interview people, I'd put in the corner B, they're going to be the builder. A, the analytical thinker. They're the person that digs deep into patents. They read the science. They read the papers. The domain expert comes often as a clinician. Someone has the domain expertise. And the organizer is the one that keeps everything running. If you don't have that skill set and everyone's an independent contributor, you don't have a team. So here's the pitfalls, though. Clinicians. Raise your hand if you're a clinician in the room, please. Raise your hand nice and high if you're a clinician. I know there's lots of clinicians here, okay? They dominate the process of biodesign and, in my mind, being an entrepreneur and innovation. Why? Because they often know from their experience what the best way to go is, but they need to temper that because medicine is experiential. We don't learn the best way. We learn the way that someone taught us. They told us it was the best way, but it isn't necessarily always the best way. Engineers tend to think the problems have already been solved. Can't be done. It's already been solved, right? And they require complete information, and my favorite thing is I need to know what the boundary conditions are to be able to solve it. They have to know all those things before they actually make decisions. The irony between engineers and clinicians, which I work with every day and I'm trained in both, is clinicians make decisions with incomplete information. Engineers want to make decisions with the most complete information there is. And business folks, the biggest complication is business folks, the goal is not to build a company. The goal is to solve a problem. The company is just the vehicle to get there. It is about developing something for patients. And sometimes it's about building a company to do that. But it's not always about building a company. So some other pitfalls, project management versus process management. We believed fundamentally in process, moving from identification to problem solving to ultimately implementation. We were not trying to manage one fundamental solution. We didn't solve it up front and try and force it down everyone's throat. We evolved over time. We cast a pretty wide net. We looked at lots of things. We looked at the coronaries, we looked at the valves, we looked at the periphery, we looked at small vessels, big vessels, and ultimately we killed things. Probably some of our biggest mistakes were killing a few things early. We also did all the things that I expect. We fell in love with a couple of our inventions. Like I said before, the solution we chose was the one we fell in love with. It was the wrong one, and luckily we abandoned it and chose a different one. And high performers, and this is for everybody in the room because I'm sure everyone here is a high performer, you fear failure. We all fear failure. Everyone's scared of failure. Here's a news flash. You're going to have to fail before you're successful. Failure is the path to success. You have to get through failure to get to success. If you're not comfortable with failure, innovation is going to be real difficult because most of the things we do are difficult. I would say the clinical paradox in all of that is that clinicians are expected to be perfect. We're judged by hopefully the few bad outcomes we've had in our career. As an innovator, you will be judged by, if you're lucky, the few successes you've had in your career, because most things don't work. Fail early, fail fast, and move on. And feasibility is about our ability to build value. How do you build value? You decrease the risk to the next stage. Incrementally knock possibilities out. Prove that something works or doesn't work and move on to the next stage. People often think I'm going to build value by doing more patients, by solving it. If you don't decrease risk, you don't build value. And there's often this problem of need creep versus need reassessment. We did this. I can tell you I did this multiple times. I've seen it lots of times, which is we identified a problem, we came up with a really cool concept, and then we convinced ourselves that the need was different than it was because we really liked the concept. That's called needs creep. And ultimately, we went back and if you revalidate the need, you will finally look at things and recognize that your concept has to match the need. Don't fall victim to needs creep. Iteration, redundancy is your friend as an innovator. Doing it over and over. Testing your lab experiments more than once. Pitching many times. Redundancy helps you get it right. It will clarify gaps in your information. The number of times for myself I've started to give a talk and I've tried to explain something and realized when I finally got it up that I didn't know what the answer was in the middle step when I had to present it to somebody else. So the key is make sure you know all the steps along the way and build in feedback loops. This is one of my favorite things, storytelling. Your ability to tell the story is not just about your ability to bring people on your side. You utilize this oral presentation to pitch, but it's not always about pitching for money. It's bringing people onto your side, gaining people's confidence, their belief in your hunger, your passion for what you're doing to hopefully solve a clinical need for patients. Again, it's not just for fundraising, and it helps address the limitations, the gaps, and areas to address feasibility. It's how you get better. Each time I pitched to someone, they would point out something they didn't agree with or they didn't understand. I answered that, went on, and the pitch got better. It helped recruit people to the team. It helped recruit basically investors along the way. And my belief is if you're pitching, if you're telling the story, and your audience doesn't understand, it is your fault, not their fault. You need to bring them on the journey. This is a redundant slide, my apologizes. On failing, another one of my favorite slides. And this goes back to that, get prepared to fail. But an inventor is always failing. It is the nature of being an innovator. He tries and fails maybe 1,000 times, and if he succeeds once, he is in. We're all looking for a little bit of success. You prepare for success. You prepare to get lucky. Luck is a component of this, but luck comes by sometimes and people aren't prepared for it. Prepare yourself for luck. So next I want to give you a perspective, that last thing as an executive. A little bit about how a strategic thinks about all these things. And what I'm going to cut to the end is we think about it exactly the same way. Nothing I've said or nothing I've tried to articulate is any different when it comes to how strategics and how people talk about exiting. Where do you exit? You exit by acquisition, usually to a large strategic. If that's the case, then you need to understand what they value. They value all the same things. The fundamental need, value creation, concepts that make sense, and how you measure outcome. That's what I look for now when I invest. It's what I look now when I acquire. So, Edwards is a structural heart company. We are only interested in structural heart. We used to be interested in critical care. We sold that business off 6 months ago. We now just do structural heart. So anything to do with structural heart, and now we are defining both valvular structural heart and non-valvular structural heart. And its common pathway of structural heart failure is what our interest is. So why do I say that? Anything that's in that space, anything we're interested in understanding. So if you're an entrepreneur that has an idea of structural heart, we're the people you want to talk to. I want to hear about it. I want the opportunity to build a relationship with you. That's how it all starts. So, Edwards has been around for 24 years. It's standard of care for millions of patients, whether they're surgical, percutaneous, anything in the structural heart space. It's a big belief in its global impact. It's 16,000 employees that serve over 100 countries. But the key is, and I wanted to walk you through this, it has an innovation strategy just like every early stage company does. Long-term commitment you see on the lower left to large unmet needs, concepts, iterations, launches, lifetime management, to taking risk. That means taking risk in early stage companies and taking risk in big swings. It also means leading with science. It means doing good evidence. It means developing milestones, clinical trials, preclinical studies, mechanism understanding, understanding markets, and ultimately, the breakthroughs we have, 95% of Edwards technologies are category leading. I was recruited by Mike Mussallem, a former CEO and chairman of Edwards Life Sciences. This was what he believed in. Edwards is first, or it's not there. It wants to be what's best for patients. That's the outcome. And so these things are similar whether you're a strategic or whether you're an early stage inventor, whether you're an early stage innovator. We all value the same things, which is the potential impact to create value for patients. Whether you can do that, there's the commonality. So to circle back with how do you create value, how do you exit, how do you create companies? You create companies that solve a fundamental problem. Typically, the opportunities are in unmet clinical problems that create value to the system that somebody believes is valuable. Importantly, I believe that today is where it creates value financially. Financially for someone. The system, if the system has the burden, they will change their behavior. A less invasive procedure, a faster recovery, hopefully is less expensive. Hopefully creates value. And that value can be translated both to the organization, but also to the entrepreneur. So that gives you a little bit of my perspective on how I think about innovation. The rest of the story was that Shockwave obviously exited this last year and now belongs to J&J. They're doing very well with it. I think it's a transformational technology, and I think it's just the beginning. It's now basically in the small vessels of the leg, the big vessels of the leg, all the coronary arteries. They've got a valve technology, and it continues to grow. This idea of using a completely different source as opposed to angioplasty that was outdated. When angioplasty was invented by Andrzej Grudzig, the balloon was actually displacing soft plaque. It was thrombus. We're now talking about hard calcium, like a rock. You need something different. And that's really what Shockwave was all about. So thank you very much for your attention. Hopefully this was useful and helpful to walk you kind of the parallels of Shockwave, basically, and how we use the fundamental process of biodesign. I hope that you are all thinking about this process in the same way. Thank you.
タッド様、素晴らしいご講演をありがとうございました。さあ、それではお写真は撮りますでしょうか。